In our video series for statistics, so far we've covered topics like data types, measures of central tendency, measures of dispersion and partition values. You can check out those videos. I'll give you the link of our playlist at the end screen and also in the video description. Also, please consider subscribing to our channel for more such content. Normal distribution is a probability distribution. It's often called as the bell curve because the graph of its probability density, it looks like a bell. The top of the bell is the mean line, and on its right and the left, you see standard deviations. In normal distribution, 99.7% of the data will fall within plus minus 3 standard deviations. There are characteristics of identifying a normal distribution. The main characteristics are that the curve will look like a bell. It will be a completely symmetrical distribution. If you would like fold it in two parts, you'll be able to see that it's exactly a complete mirror image. And in normal distribution, the thumb rule is that the mean, median and mode will more or less be the same. Today we'll understand what normal distribution is and how to test normality using Minitab. Let's understand this with an example. I have randomly plotted some numbers for 100 students and we plotted the heights of those individuals. In order for us to identify the normal distribution, first thing that we have to do is to identify the mean, that what is the mean of that given sample. It's a pretty simple, straightforward formula. You have to take an average of the entire sample that's been given. And then you calculate the standard deviation. We've already covered how to calculate mean and standard deviation in our previous videos. You can take a look at that. Now, in order for us to identify the distribution, if the mean is 5.049 and if I will reduce one standard deviation out of it, the value will become 4.54. If I'll reduce two standard deviation, then the value will become 4.045. And if I will reduce 3 standard deviation, then the value will become 3.544. Similarly, we've added 1, 2 and 3 standard deviations to this value. And if I would plot this on a bell curve, the bell curve would look something like this. Now, if I were to conclude by virtue of looking at this distribution, we can say that 99% of our students' height will eventually fall under 3.54 to 6.55. Now let's take this data to Minitab and understand how can we do the normality test. I go to Stat, I go to Basic Statistics, and here is the option for normality test. It says, determine whether your data follow a normal distribution used when you have continuous measurements such as length or weight. I will double click on height and I can click on OK. We're doing the Anderson-Darling test for normality. And as you can see, the probability plot, all the dots are pretty much very closely attached or very closely tied to this red line that is moving from top to bottom. When you see all the dots are close to this red line, you can assume that the data is following the normal pattern. The second way to identify whether data is normal or non-normal is looking at the p-value. If your p-value is greater than 0.05, you can conclude that data is following normal distribution. Now, you may have seen me doing some experiments by tweaking the data a little. I have tweaked this data a little by changing the number of the same series every 10th number. Every 10th number of the series I have changed it to 8. So now the height of every 10th student in the class is 8. If I will plot this on Minitab, let's see how the numbers and the graph would change. Now, if you would compare these two probability plots, you can easily find out that 1, the blue dots are not absolutely close to the red lines, plus there are some points that are even far from the red line. And the p-value is less than 0.05. And in our previous case, the p-value was greater than 0.05. If the p-value is greater than 0.05, you can say that data is normal. On the other hand, if the p-value is less than 0.05, you can say that data is non-normal. One of the reasons why we're required to do the normality test It's because many of the statistical validations that we do through hypothesis testing, we're required to find out whether data is normal or non-normal. We'll try and cover those in our upcoming videos, and do let us know in the comment section if you have any questions specific to this topic. Thank you so much for watching. Please subscribe to our channel and I'll see you in the next video. Thank you once again.